Welcome to the lair of the Batty Boffin.
Hi there Batty fans, it's time for a little bit of GCSE exam questions with Batty Boffin. Here we're doing higher level GCSE maths. We've got Bathilda the Batty cat with us, as ever, our mascot for these questions. And here Bathilda has got a field that she likes to run around at night hunting for mice. As she runs around the edges, she estimates that these are the lengths of the sides of the field. So 82, 40, 45 and 31 metres. Also, being a very mathematical cat, she has estimated the sizes of a couple of the corners, 74 and 131 degrees. Now, for the first part of this question, Bathilda wants to know, is that field actually a trapezium? It does look like one, but is it approximately a trapezium? So part A of the question, work that out. Have a go now. Okay, let's go through that together. In order to be a trapezium, we need the top and bottom to be parallel. And to find that out, we're going to work out this distance and see if they are pretty much the same. So, how are we going to do that? I feel a little bit of trig coming on. If I drop a vertical down here, we've got a right-angled triangle. Now, a right-angled triangle, of course, you're going to be doing either Pythagoras or trig. Since we've got angles, it's trig. I'm not going to be explaining how to do trigonometry here. If you need to know that, check out one of the other Batty Boffin videos. I'm going to assume that you know what you're doing. So here we've got our right-angled triangle, and we need to know this bit of the angle here. Well, if that bit's 90, then that bit there is going to be 41 degrees. That's that bit there. And now is where we come to our soka to'a, which you say like it's a badly dubbed karate movie. So, ka, to'a. And if you wish to do a few karate moves along with that, that's entirely up to you. Okay, so here's our three little formula triangles. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. In our particular triangle, there's our angle. We want to find this side, which is the adjacent, and we've got this side, which is the hypotenuse. So we're going to be using cosine. As always, I'm just going to get a different coloured pen. Ooh, here we go. We cover up the thing we want, which is adjacent, and what's left is the formula for it. So adjacent is cosine times hypotenuse. So the cosine of 41 degrees times by the hypotenuse, 40, will give us the adjacent. Stick that in a calculator. What have we got? We need the cosine of 41 degrees is that, multiplied by 40, gives me 30.188888. So that's 30.19 equals 30.19 metres. Okay, so that's the first one. We're going to do a similar kind of thing over on the left-hand side. Again, drop a vertical. This time we're wanting the opposite. So we're going to use sine, because sine is opposite over hypotenuse. So here we go. The sine of 74 degrees multiplied by the hypotenuse, 31, equals the opposite. Again, grab our calculators, and we're going to do the sine of 74 degrees is that, multiplied by 31 is that, and it comes out to 29.799. So it's to 2dp, 29.799 to 2dp is 29.80. Okay, 2dp on there. If it says 2dp, you put 2dp. Okay, so there are our heights. We've got 30.19 and 29.80. Yeah, they're pretty much the same, aren't they? So yes, this is approximately a trapezium. Now, we're going to have one of those things where it goes black and it comes white again, where I wipe down this and we're going to do part B. See you in a minute. Right, so I've put the height in here that we calculated in part A, and for part B, Bathilda wants to know about the area of her field. Now, she's got quite short legs, so the maximum amount of field that she can cover while hunting for mice in one night is 1,950 square metres. Now, these of course are all estimates, these metres here, so these are all correct to the nearest whole number. And what Bathilda wants to know is, given that these are estimates, can she be sure that she can definitely cover the whole field in one night? You go and calculate that now. Right, let's work through that together. Now, the first thing, of course, you're going to need to know here is how to work out the area of a trapezium. Hopefully, again, you know that. A lot of quadrilaterals, it's base times height. For a trapezium, it's very similar, but it's average base times height, because obviously we've got two bases on here. So to calculate the area of this trapezium, just as it looks at the moment, you might think you're just going to do average base, which is 82 plus 45 over 2, so that gives you the average base, times the perpendicular height. Okay, so you could do that calculation and it will come, I believe, to 1905 square metres. And you look at that and you go, yeah, sure, that's fine, no problem. 1905 metres, she can do more than that, so yes, she can definitely cover the field. But hold your horses. These were only approximations. We need to look at the upper and lower bounds for this. That 40 could actually be 40.5 to the nearest one. That 30 could be 30.5 to the nearest one. This 82 could be 82.5 rounded off to the nearest one. When you're doing upper and lower bounds, you go half a unit up and half a unit down. Since we want the upper bounds on here, we need to rewrite this. Same formula, different numbers. So instead of 82, we're going to use 82.5. And then for the 45, okay, actually it's 82.499999999, okay, strictly speaking, but however many decimal places you want, it will always round to 82.5. So 82.5 for the upper bound of that, 45.5 for the upper bound of that. The divided by 2 stays the same. You don't need to change that to 2.5 because that's just part of the averaging thing. Times by, and the distance between them, 30.5. Okay, so if we pop that into the calculator, we get, what do we got? 82.5 plus 45.5 equals that, divided by 2 equals that, multiplied by 30.5 equals 1952. 1952 square metres. So, if all of those dimensions are as big as they might be, Bathilda, the Batty cat, will not be able to cover the whole field in one night. Now, probably chances are they're not, so she probably would be able to, but we cannot guarantee it. So the answer to this question is no, we cannot guarantee that she can cover the whole field in one night. Right, that's the end of this question. I'll see you again for some more GCSE questions in another video. Bye for now.